Our topic for today is graphing sine and cosine. And next class we'll do graphing tangent, cotangent, secant, cosecant. But today we'll start with sine and cosine. So in my 1A, I think I wasted too much time having everybody help me graph sine and cosine, so I'll just do that quickly for you all. You guys have seen the graphs, right, before? Yeah, okay. So let me graph sine first. So something super important that helps you identify the graph of sine x is the fact that sine 0 is 0, okay? That would be very helpful. Okay, sine 0 is 0, which means that this graph has to intersect the origin, right? So that's at least one point that we know. Let me draw some more tick marks. Pi over 2, pi, 3 pi over 2, 2 pi, and then the negative direction, negative pi over 2. So I would copy this graph in your notes. It's important to know how to get some practice doing this. Okay? And the maximum possible value for sine x is 1, and the minimum possible value is -1, right? Because it's a unit circle, so it can't exceed 1, or it can't be less than -1 either. So here are some important points on the graph that it simply connects, okay? So sine pi over 2 is, anybody? 1. Okay, no more degrees in this class, please. Sine pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is 0. You guys can confirm this at home in your free time. Sine of -pi over 2 is -1. And sine of -pi is 0. And sine of -3 pi over 2 is +1. Okay? So, graphing this is basically just connecting the points except in a smooth and squiggly line. If you've ever seen waves, it's just shaped like waves. Okay, so it's going to look like this. Make sure it's smooth and okay. So one really important thing to help you identify this is sine is that it intersects the origin and it intersects the origin with a positive slope. Okay, positive slope. On the other hand, if you had negative sine x, it would intersect the origin with negative slope, which we'll see in a second. Okay, so this is the graph of sine x. And let's do cosine x right now as well. So cosine x actually has the same exact shape, but it's shifted. Okay. So for cosine x, it's very important to know that cosine 0 is 1. All right, I would memorize these two values. Sine 0 equals 0, and cosine 0 equals 1. I would just memorize those. It'll help you graph. All right, so once again, I'm going to plot some points. 1, -1, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, -pi over 2, -pi, -3 pi over 2. Okay, and then cosine 0 is 1, so that's here. And then the pattern is going to be pretty much the same. Cosine pi is -1, cosine 2 pi is 1 again. And same for the negative side. Cosine is even function, right? So you'll notice it's symmetric across the y-axis. And so when I connect these points, I get this. All right, so it's the same exact shape as sine, except it's shifted to the left, right? Because now cosine 0 has to intersect the y-axis at 1. So that's how you always are able to identify that it's cosine. It intersects the y-axis at its maximum. intersects the y-axis at its maximum. whereas sine x intersects the y-axis in the middle of its course. Got it? Questions? Okay, so two words to know, period and amplitude. So the period of both sine and cosine is 2 pi, right? So a period is just the length over which it repeats. So in this case, the period would be 2 pi for both of them. You can either think of it as the distance between the kind of the crests, the peaks, or also the distance between the troughs. Do people still know that word, trough? Good. That's all 2 pi, right? So that's why the period is 2 pi. It repeats every 2 pi. Same for cosine. This is period. So period is 2 pi. If I get sick again this week, I'm actually going to quit this job. Okay, and the amplitude is 1. Okay. You can think of the amplitude as half the distance between the maximum and the minimum. So it's the distance between the middle of the graph and the maximum. Amplitude is 1. Okay, don't get confused. It's not 2. It's actually just 1. Between the middle and the top, essentially. Right, because sometimes these graphs will be shifted, so it's not always the x-axis in the top. Well, that is actually the topic of our next slide. But any questions here? Anybody?
Is that a sine wave?
Yes, that's why they call it a sine wave, obviously. It's a sine. Yeah, so in real life, you know, all the waves you encounter, whether those are sound waves or light waves, those are just trig functions, right? Ocean waves.
Ocean waves?
Yep. I mean, away from the beaches, ocean waves are always, right?
If you take the amplitude that's below x equals 0, or y equals 0, then would you get?
Sure. This is also 1.
Amplitude?
Nope. Amplitude is always positive. Okay. So you know, if you guys go into engineering, you guys will learn something called Fourier decompositions, where any shaped wave can always be decomposed into the sum of multiples of sine waves. Anyways, that was totally irrelevant.
So the amplitude is going to be half the distance between the top and the bottom.
Mm-hmm. Yes. Okay, right? The distance between top and bottom is 2, so the amplitude is 1. Okay, next slide. So next we have to talk about vertical shifts and stretches, which is the easy part of today. Okay. So you might encounter stuff like this. What is, a sine x plus d? I think that's the word, the letter I use. Okay. Well, from sine x, that's just a, first it's going to be a vertical stretch by a factor of a, right? We all remember this. That's going to bring us to a sine x. And then the next transformation would be a vertical shift by d. That would bring us to a sine x plus d. Okay? So that's vertical shifting and vertical stretches. We also have vertical reflections, right? So the other possibility is, maybe negative sine x. That is a vertical reflection across the x-axis. Okay, so 2 or 3 important vertical transformations to know, and we'll look at some examples. Okay, let's first think about what a vertical stretch would look like. Okay, so if I had, let's say, if I were to draw sine x in red and maybe 2 sine x in blue, then it would be a vertical stretch. and my amplitude would change. Okay? So let's say this is 2, this is 1, -1, -2. Well, sine x, as I know, it has to cross the origin with a positive slope. Sine x will always do that. So I'll start drawing it like this. Also have to go backwards. Okay, so that's what sine x would look like. I might add some tick marks, pi and 2 pi. Right, the reason I know that's pi and 2 pi is because the sine x has a period of 2 pi, right? So this distance has to be 2 pi. And then pi is just halfway between that. Okay, well, if I were to do 2 sine x, that would just be a vertical stretch by 2, right? So that would look like this. It would intersect the x-axis at all the same points, but now the maximum and minimums are all stretched out and stuff. Too tall. Okay, any questions? So that's vertical stretches. Any questions? Let me also do an example of a vertical shift. Let me try this. See if I'm smart enough technologically. Wait, what? I'm trying to select this so I don't have to draw it all again. Does that work? Duplicate. And then I go to the next slide. Paste. Oh, I'm such a genius. Okay. Great. Okay. So this time let me do a stretch, okay? Sorry, a shift. So let's do sine x and then sine x plus 1. Okay, what kind of transformation would that be? Sine x plus 1? Vertical.
Vertical shift.
Whoever said that. Over there. Oh, I should do it in blue, right? Sine x plus 1. That would be a vertical shift upwards by 1. And so that would look like this. Everything would be shifted up by 1. So now it's going to intersect the y-axis at y equals 1 instead of y equals 0. Okay? But I still know it's a sine function because it's intersecting the it's still intersecting the y-axis at the middle of its course and in a positive direction. So I still know it's positive sine x. I just don't know whether it's now it's shifted, right? So that's how I get that. Okay, any questions? That's just a shift. And finally, let's do a reflection question. Yeah. Let's do a reflection finally. And everything is also the same for cosine. It would just be a little different. It would be shifted left, right? Okay, so if this is sine x, then negative sine x is going to look like this. Everything would be reflected this time across the y-axis. So it would be like that. Okay? So you'll notice that now in the blue, right? Now negative sine x, it still intersects the origin, but it intersects the origin with a negative slope now. So that's how you can tell it's a negative sine function, when it intersects the origin or the y-axis with a negative slope. Okay? Okay, let us look at some
So
combinations of
negative
those.
sine x is not equal to cosine x?
No. Yeah, no. Okay, let's look at now combinations of both vertical stretches and shifts. Thankfully, it's not too tricky. So let's do, for example, 3 sine x plus 2. And your question on your quiz asks you to graph this. Let me show you what you would need to do for full credit, okay? Generally, a good first step is to first find the maximum and the minimum, or maxima and minima. Okay, so to do that, what you do is plug in 1 and negative 1 into sine. Sorry, not into sine, but as sine. So for example, because you know that the maximum of sine x is 1, the maximum of this new function would be 3 times 1 plus 2, which is 5, right? And the minimum of this new function would be 3 times negative 1 plus 2, which is negative 1. Got it? So that's our new maximum, and that's our new minimum. And of course, the average, or the middle line of this would just be 2, right? Like the average. Okay? Average is always going to be whatever you're adding on to the end, right? So the constant you're adding on to the end is always going to be the average, because the average of sine x is just 0. So the new average is just whatever you're adding on. That's a good way of looking at it. Okay? Then what I would do is I would draw my axes. That would be my next step. It just helps us to graph it. Otherwise, it doesn't look good when you graph it. Okay? Then I'm going to draw 2 tick marks. That's all you need for full credit. You just need 2 tick marks. All you need to do is indicate the maximum and the minimum. I don't care about any tick marks in between. Okay, so don't waste your time with those. Then I'm going to draw like maybe a dashed line through 5, because that's my maximum, right? It's kind of like the roof of my sine function. Like it can't go over that, but it's always going to touch it. And then negative 1 is my floor, minimum. And then my average is in between, right? That's at 2. And so that's kind of like the middle line, midline of my sine function. Okay? Then all I'm going to do now to graph it is simply draw my sine function, except, translate it upwards with these new boundaries. Okay? So that's just going to be this. I'm going to draw starting from my first period. Oop. So it has to intersect the y-axis through the middle line, right? So that's why I care about that middle line. Not the best graph. Okay. And then, in order to get full credit, you also need 1 to 2 tick marks every period on the x-axis. Okay, 1 to 2 tick marks every period on the x-axis. And how do I know where they're going to be? I know they're going to be wherever my graph intersects the middle line. So that's going to be 2 pi, because that corresponds to this point here. And then this point corresponds to pi. So here's 2 pi, here's pi, here's negative pi, and then here's negative 2 pi. Okay? The reason I know that is because sine is always 0 at multiples of pi. And when sine is 0, that means my graph is going to be crossing this middle line, right? Because when sine is 0, the function is equal to 2. So that's how I know that whenever the function equals 2, my x value has to be pi or 2 pi or 3 pi, something like that. Okay, so this graph would receive 5 points out of 5 points. And that's all you need. You don't need to tick marks in between here. I don't care about those. Questions?
Does 0 count as a tick mark?
Yes. Okay, yeah. Okay, any other questions? Let me also show you an example of doing it in reverse, which is also on the quiz. So sometimes, now would be a good time to go to that study guide. Sometimes you will receive a graph and you will have to identify what the original function is. So let's say we have maybe, what's a good one? Maybe this guy here? No. Here's good. Okay, I think this is also on the homework, so. Okay, so sometimes you're going to be given this graph and you'll have to convert it back into its original function. So I'll show you the steps for that. Okay. First step is you want to identify the maximum and the minimum. So the maximum is 8, obviously. The maxima is at 8. And the minima is at 0, right? Because it's touching the x-axis. So that tells you that the average is 4, right? That's kind of like the middle line of the graph. And so you know that whatever thing you're adding on to the end, it has to be 4. So C is definitely 4. Got it? Well, I forgot to tell you guys this, but A is always the amplitude of our graph. Okay, so going back to our graph here, A is always the amplitude. So in this case, the amplitude would be 3. All right? And why is it 3? That's because the distance between our middle line to the top is just 3. You could also think about it as half the distance between the maximum and the minimum, which is 6. So half of that is 3. So that amplitude is always going to be the number that you have in front of the sine function, or the absolute value of the number, because the amplitude is always positive. Okay? So that tells us that A must be 4, okay? Or negative 4. And the trick is having to determine whether it's 4 or negative 4. In this case, we know it has to be negative 4, okay? The reason is because 4 cosine of x plus 4 would actually look like this. It would actually look like this, okay, in the red. And the reason is because cosine of 0 is 1, right? And so 4 times cosine of 0 would actually give 8. But clearly, this graph is inverted, right? It's flipped across the, it has a vertical reflection. And so that tells us there must be a negative sign in front of cosine, right? So we can check, right? Negative 4 times cosine of 0 plus 4 is actually equal to 0, which is a better fit with the actual graph that we see here. So our final answer would be negative 4 cosine x plus 4. Okay. Questions? Okay. Maybe you guys can try question 4. I think it's good. Okay, find the function y equals a sine bx plus c. B here is 1. Okay, well, we're only going to cover that later in a few minutes. But so find the maximum, find the minimum, find the amplitude, find the average line. Okay. What's the maximum?
6.
Minimum?
4.
Average?
5.
Amplitude?
1.
1. Thank you. Amplitude is 1 because it's half of the distance here, right? So that tells us that C has to be 5 because that's our vertical translation upwards, right? And the amplitude is 1. So the answer is y equals sine x plus 5. Okay? And the reason we know it's positive sine x and not negative sine x is because it intersects the y-axis with a positive slope, okay? I'll show you what y equals negative sine x plus 5 would look like. Y equals negative sine x plus 5 would look like this. It would intersect the y-axis with a negative slope. See here? Okay. So because the function has a positive slope going through the y-axis, we know it has to be positive sine x plus 5.
Do you have to write maximum, side, minimum, average, and amplitude?
You don't have to write it. Yeah.
Would it be helpful, right?
It's very helpful. Any questions? Okay, well, that was the easy part, so let's do the hard stuff now. Hard stuff is horizontal transformations. It's always tricky, isn't it? Okay, and then what's even worse than that is combinations of both horizontal and vertical transformations, which will be the topic of our group quiz next class.
Is it gonna be like the other group quiz?
What do you mean the other group quiz?
Are we gonna
Like,
have different?
when we gonna do it, and then you feel me, like.
No, it is going to go in. Because people will not be cheating on it this time. I shouldn't have said that on the recording. Okay. Let's say we have something like sine of bx. Okay, what kind of transformation is that?
Horizontal compression.
Thank you. Horizontal compression or shrink. Right? Remember horizontal stuff? It's kind of the opposite of what we think. Right? So because it's multiplying by b, this is a horizontal shrink by a factor of b. Okay? So originally our period was 2 pi, right? The period of our sine and cosine functions. That was originally 2 pi. But now it's going to be 2 pi over b, right? Because everything's being compressed horizontally. So the new period is 2 pi over b. These are some formulas I would encourage you to memorize.
How many questions is the group quiz?
I forgot. Okay, period is 2 pi over b. And you can also rearrange this. B is also 2 pi over the period. So they're easy to remember, right? Memorize. Right, so if you were asked, what is the period of sine 3x? What's the answer? That'll be 2 pi over 3. Because b is equal to 3, right? So the period is 2 pi over b. On the other hand, if you were given, right, let's say your period is maybe 3 or 4. Let's say 3. Let's say 3. Okay. Let's say you're given the period of your sine function is 3. What would b be equal to? Well, you would just plug it into your formula. Then you would know that your function would have to be sine of 2 pi over 3x. Okay? Because you can just use this formula to calculate what the constant b has to be in order for the period to be 3. Okay? Good formulas to remember. So I'll show you guys how to quickly graph this. Yeah. So let's say you were given the function maybe cosine of 4x, and you were asked, oh, please graph this. Well, here's the way I usually do it. So my personal way is that, or what I think you guys should do as well, I would just draw the graph normally at first, and then add the tick marks in later to indicate that it's been shifted. Okay, so I'm going to draw my cosine function. Now cosine, cosine 0 is 1, right? Cosine 0 is 1, so it has to intersect the y-axis at 1. So that my graph would look like this. Okay? So my first step is going to be calculating the period. So I know that the period t has to be 2 pi over b, which is 2 pi over 4, which is pi over 2, right? So I know that the distance between my peaks should be pi over 2, so that tells me that this tick mark should be pi over 2. Okay? Which means that this tick mark at the trough would have to be pi over 4. And this check mark, negative pi over 4. Negative pi over 2. And then finally, to get full credit, I also have to indicate one tick mark here and a minimum tick mark here. Okay, and that's a 5 points out of 5 points graph. I am so hungry. Any questions?
No, sir.
Okay. Well, sometimes, right, you also might be given a function and you're asked to find, oh, what is the, given the graph and you're asked to find what is the function. So you need to be able to do it in reverse as well. So for example, question 3 on the study guide. Your first step is to notice, okay, so here, my amplitude is still 1, right? Because the maximum and minima are 1 and negative 1. So A is still 1, so I have no problems there. But here, what I would do is I would first calculate the period and then use that to find what B has to be. Okay, so in this case, the period is 10 pi, right? Period is 10 pi, because that's the amount that it takes for one cycle. Be careful, the period is not 5 pi, okay? Even though it intersects the x-axis again at 5 pi, the period is actually 10 pi. You have to go one entire cycle. So because the period is 10 pi, that tells me that B equals 2 pi over 10 pi, which is equal to 1/5, right? So that means y equals sine of x over 5. And I'm done. Okay. You can think about it again. Sine of x over 5 is a horizontal stretch by a factor of 5, which is indeed what I have. I'm going from 2 pi to 10 pi. Questions? Okay. All right, now for the hardest part, horizontal shifts. You know, trig is just going to keep getting harder day after day. It's like life. Okay? Sometimes you're going to be getting sine of bx minus c. And so that is going to be a pretty complex series of horizontal transformations. As a general rule, always remember that stretches come before shifts. Okay? Stretch first, then shift. Anybody have a good mnemonic for that? And so to find the shift, you actually need to factor out the b term. So factor out the b from both terms, and you're going to be left with b times x minus c over b. And this actually would first correspond to a, shrink by b. Shrink by b, and then shift by c over b. Okay, that's why it's tricky. It's not a shift by c, but actually a shift by c over b. Okay, and the shrink comes first. All right, let me show you guys a simple example. Let's say we have sine of x, maybe sine of x plus pi over 2. Okay? Okay, but by the way, this is a shift by c over b to the right because it's a minus sign, right? A minus sign corresponds to a horizontal shift right. Okay? So if we have sine of x plus pi over 2 as our question asking us to graph it, well, this is just a shift right by pi over 2 starting from sine of x. Okay? Sorry, shift left. Nobody corrected me. Shift left pi over 2. So if our original graph, this is going to be a pretty trippy graph. If our original graph looks like this, no. Okay, if this is our original graph, and then this would be pi, right? This is 2 pi. This is negative pi. Well, our new graph, sine of x plus pi over 2, would be a shift left by pi over 2, which would look like this. Okay. Anybody notice anything interesting? Well, it's just cosine of x, right? So that's an interesting fact that you can confirm for yourself at home in your mind. Okay. Kind of also looks like a DNA helix a little bit in this diagram, although they are different. Any questions? Yeah. So this is probably the trickiest part. And let me go over an example. Okay. Sometimes you might be asked to identify something like this. Okay. Let's say find the function y equals sine of bx minus c. Okay. Your first step is to find the period. Okay. And the period will help you to find b. Okay. So in this case, what is the period?
3.
Thank you. 3. Right? Because that's one cycle, right? And that's 3. So that means big T equals 3, which means that b equals 2 pi over 3, right? Because b equals 2 pi over t. So that means b is equal to 2 pi over 3. So we would write y equals sine of 2 pi over 3 times x minus c over b. Okay? It's quite important to actually have that within the parentheses, right? Because that's the only way the shift is going to be correct. Okay? Does anybody know how it's shifted? How much it's shifted by? That's the tricky part of these questions.
0.
Nope. It is actually shifted by 3 over 2. The reason is because a normal sine function looks like this. It crosses the, right? A normal sine function always crosses the y-axis with a positive slope. So that means it has been shifted. It has been shifted by 3 over 2 to the right. Therefore, c over b must be equal to 3 over 2. So our answer is y equals sine of 2 pi over 3 times x minus 3 over 2, which is equal to sine of 2 pi x over 3 minus pi. That's our answer.
Now, how do you know if it was shifted to the left or to the right?
Doesn't matter. Give you the same answer. Why is that? That's because that's just equal to this, right? Plus 2 pi. That doesn't change the value of sine. That could also be minus plus pi, right? So minus pi plus pi, that doesn't matter. Notice that this is actually also equal to negative sine 2 pi x over 3, right? You could also see that visually speaking, this is also a reflection of sine x across the x-axis, a vertical reflection. So both answers would be mathematically valid, but the question is asking for positive sine x of bx minus c. So this would be our answer. Okay? Very tricky, and you need to become an expert in transformations. That sounds like something they would say in Harry Potter, which I was watching last week a lot. Yes?
What do you think the average for the group of boys will be about the graphing?
70%? I don't know.
So what?
70%? Okay. I mean, we haven't even gotten to combinations of vertical and horizontal. And you know, that's pretty straightforward. You just need to think about them separately, right? Because they don't influence each other, if that makes sense. If you think about them on separate terms, you'll get the right answer. Okay, let me do a hard question. Are there any hard questions?
It's too easy, like, come on.
I agree, right? Yeah. What is this class, you know? This is child's play.
Hey, it was not. be mixed up? We're gonna-
Wait, what?
Can our groups be mixed up?
That's quite insulting. Let me do question 15, which is the hardest question, I think. Okay. Let's do the vertical transformations first, because that's easier. Okay? Can somebody tell me the maximum?
1.
Negative 1.
Negative 1. Wait, oh, negative 1.
Minimum?
Negative 5.
Average?
Negative 3.
Negative.
So the amplitude would be, thank you. Remember, it's always positive, so amplitude is 2. Okay. So that gives me the vertical stuff. So I know that A has to be equal to 2 and D has to be negative 3. So that's easy. Okay, what is the period? Well, one cycle is clearly 2, right? You could either think about that or also this distance between the peaks. That's also 2. So the period is equal to 2, which means that B is equal to 2 pi over 2, which is pi, right? Okay. Now the next thing that has happened is also a shift, right? Because okay, B is pi, so that means sine of pi times x minus something. What is the shift? Well, normally sine x would intersect the y-axis with a positive slope, so it should look something like this. But clearly it's been shifted by 1 unit to the right. So that means it's sine of pi times x minus 1 or sine of pi x minus pi. So that would be the stuff inside my sine function. So my final answer is y equals 2 times sine of pi x minus pi minus 3, right? Because d is negative 3. So that's my answer. Another acceptable answer would have also been y equals negative 2 sine x pi x minus 3. That's the same. Right? And why is that? That's because this is also it's also a vertical reflection, right? So negative also works. Okay, pretty tricky. That's the hardest, but I don't know. Maybe even harder is actually being able to graph this based on just the function you're given. So you have to do it in reverse. You have to not only graph but also identify graphs. Pretty tricky. And our quiz will be next class.
Is the quiz going to be as hard as this?
Quiz will be as hard as the group quiz.
No. Is the group quiz going to be as hard as this? Is that on the group quiz?
Some of them will be this hard.
Is it group quiz next class or next class?
Next class.
What do you think the average is going to be for that quiz?
Let me say it off camera.